All right. So now I want to make one last remark before we finish with exponents. And I'll try to sell this to you in a lot of ways as the course goes on, but one thing that I want to try to emphasize is that the natural logarithm really is natural. So I claim that the natural log is natural. And the example that we're going to use is, for this illustration, is economics. Okay? So let me explain to you why the natural log is the one that's natural for economics. If you are imagining the price of a stock that you own goes down by $1, that's a totally meaningless statement. It depends on a lot of things. In particular, it depends on whether the original price was $1 or $100. So there's not much meaning to these absolute numbers. It's always the ratios that matter. So for example, I just looked up an hour ago, the FTSE, the London exchange, closed, and it was down 27.9, which, as I said, is pretty meaningless unless you know what the actual total of this index is. And it turns out it was 64.32. So the change in the price divided by the price, which in this case is 27.9 divided by 64.32, is what matters. And in this case, it happens to be 0.43%. All right, that's what happened today. And similarly, if you take the infinitesimal of this, people think of days as being relatively small increments when you're investing in a stock. You would be interested, in the infinitesimal sense, you would be interested in p prime over p, the derivative of p divided by p. That's just the natural log prime. So this is the, let me just put a little box around it. It's just the formula of logarithmic differentiation. But let me just emphasize that it has an actual significance, and it's the one that's used by economists and people who are modeling prices of things all the time. They never use absolute prices when there are large swings. They always use a log of the price. And there's no point in using log base 10 or log base 2. Those give you junk. They give you an extra factor of log 2. It's the natural log that's the obvious one to use. It's completely straightforward that this is a simpler expression than using log base 10 and having a factor of natural log of 10 there, which would just mess everything up. All right, so this is just one illustration. Anything that has to do with ratios is going to encounter logarithms.